Every single time you flip a light switch, you're actually tapping into a couple of invisible superpowers. Seriously, today we're going to pull back the curtain and look at these two incredible forces, magnetism and heat, that are just hiding inside a simple electric wire.
All right, so let's set the scene. We're at a super busy school science fair, and we're following two curious students, Mohini and Akash. They're checking out all the projects, but one model just stops them in their tracks.
They're looking at this little model crane, right? But it doesn't have a hook. Instead, there's this iron nail wrapped in a bunch of wire. And get this, someone flips a switch, and suddenly that nail starts picking up paper clips, just like a magnet. But there wasn't a magnet anywhere, just a battery and some wire? So what in the world was going on?
And that little crane model leads us to a massive question that scientists wrestled with for a long time. Can an electric current, actually create some kind of invisible force?
Well, here's your proof, right here. Check it out. On the left, the circuit is off, and the compass needle is just sitting there, doing nothing. But look at the right. The second we let that current flow through the wire, bam! That needle moves. It's totally reacting to that invisible force.
This amazing phenomenon has a name, of course. It's called the magnetic effect of electric current. And what that really means is that a simple flow of electricity creates its own magnetic field all around it. The wire itself basically becomes a magnet. And believe it or not, this wasn't some recent breakthrough. This whole thing was discovered completely by accident way back in 1820. There was this scientist, Hans Christian Ørsted, and he was in the middle of a lecture. He just happened to notice a compass needle twitching nearby every single time he turned on his electrical setup. And that one little accident, that tiny observation, it was absolutely revolutionary. It kicked off a whole new field of science.
Okay, so if we know that electricity can create a magnetic field, that leads to a really cool idea, right? Can we actually use that force? Oh, you bet we can. We can use this very principle to build our very own magnets.
And that's exactly what an electromagnet is. It's really just a coil of wire that acts like a magnet, but here's the key. Only when you've got an electric current flowing through it. The moment you turn that power off, poof, the magnetic effect is gone.
And this is something you can totally build yourself. It is so simple. All you need is an iron nail, some insulated wire, and a battery. You just wrap the wire around the nail, connect the ends to the battery, and boom, just like that, you've made your own magnet.
But here's where it gets really cool. You are in complete control. If you want a stronger magnet, easy. Just add more turns of wire to your coil. Or, use a stronger battery. You can even flip its north and south poles just by changing the direction of the current. It's like having a magnet with an on-off switch and a volume knob. That control, that is its real superpower.
And this shows you just how big this simple idea can get. I mean, the exact same principle that lets a little nail pick up a paperclip is what allows these huge, massive industrial cranes to lift and move tons and tons of scrap metal with perfect control.
But hold on, creating magnetism isn't electricity's only superpower. It's got another incredible trick up its sleeve. Turns out, it can also produce heat.
So check out this experiment. We've got a special kind of wire here. It's called nichrome, and it's hooked up to a battery. Now, after only about 30 seconds with the switch on, that wire starts to get pretty warm. So why does that even happen? Well, you can think of it this way. The wire itself is actually fighting back against the electricity trying to flow through it. We call that resistance. And honestly, the best way to imagine it is like friction. You know how when you rub your hands together, they get warm? It's the same idea. This electrical friction turns electrical energy into heat. And we have a name for this, which is, you guessed it, the heating effect of electric current. All it means is that when you pass electricity through something that has resistance, it's going to heat up. Simple as that.
And I guarantee you use this effect all the time, probably without even thinking about it. Those glowing red coils in your toaster, the burners on an electric stove, the hot air coming out of your hairdryer, or the heat from an electric iron. Yep, they all work because of this one basic principle. Okay, so all this magnetism and heat, it's all amazing. But it kind of makes you wonder, right? Where does all this electricity even come from in the first place? Like, what's actually happening inside that little battery?
Well, you can think of a battery as basically a tiny chemical factory. Inside of it, you've got two different metal plates, we call those electrodes, and they're sitting in this special liquid called an electrolyte.
It's the chemical reaction happening between all those parts that actually pushes the electricity out and gets it moving through the circuit.
So let's recap. We've seen electricity's two incredible superpowers. It can create magnets, and it can create heat. And that leaves us with one final, kind of mind-bending question to chew on. If an electric current can create a magnetic force, could it work the other way around? Could a moving magnet create an electric current? That's something we're going to have to explore next time.